Okay, so welcome once again to the question number 3. This is on the concept of HR diagram. And if you want to know more about the HR diagram, you can refer to my previous video, which is on theory of the HR diagrams, what information you can get across. This is already there in the playlist. Okay, now let us look at this. This question is taken from May 2006 paper HL, and it was from the third paper. Okay, earlier this was the paper 3 portion, so we are taking it from here. Okay, now once again, the HR diagram below shows the position of a star on a main sequence. The star has 4 times the mass of the sun. Where is the star here? Star is somewhere over here. Star is somewhere over here. So this is now currently in a main sequence star. So this is your main sequence star, right? Okay. Then this is your red giant. This is your red super red giant. This is your red super red giant. This is something which you need to know. Okay, and then this is your white dwarf. Now we have named the clusters. We have not asked you to name the clusters, but we have named it for the sake of convenience. Okay. Now there is one star over here which has a mass equal to 4 times the mass of sun. Mass of the star is equal to 4 times the mass of sun. Then on the HR diagram, draw the evolutionary path followed by this star as it leaves the main sequence. Definitely it will leave the main sequence because mass is higher and higher. So when the mass increases, what will happen? When the mass increases, what will happen now? Okay, the fuel, what you call as a hydrogen, okay, gets depleted off. Right? When it gets depleted off, what will happen? The star swells. The star size increases. Okay, then it becomes a much larger star. It becomes a super red giant. Then this will continue for a few years because he's asking for evolution. He doesn't say what happens next second. Okay, so evolutionary, what will happen? So therefore the star, you can say it goes like this. Okay, it doesn't mean there is a path of the star. I'm just telling you the transition of the star. Okay, I'm not pinpointing only one star over here. It can be any one of the stars. Okay, so don't consider this equal to a projectile motion or anything else over here. So I'm just drawing a mind map or a diagram to indicate what could be the evolutionary state of this star. So it goes over here. Now it is in the state of supergiant. Now this could take billions of years to happen. Now once it is supergiant, what will happen? After some time, okay, there will be an explosion being formed, and after explosion, what will happen? There will be a planetary nebula being formed. There will be a planetary nebula. Which means what? The gases which are outside this. See, this is the core. This is the gas over here. This gas will expand and this will blast away. Planetary nebula, a lot of cloud and dust will be formed. And there is a core over here. Okay, so there is no fuel over here. There is nothing burning inside it. And as a result of it, there is a lot of helium atoms which are present over here. These helium atoms is not doing anything, and as a result of it, what happens? The temperature in it increases. Right? The temperature increases. When the temperature increases, and there's a lot of gravitational pull inside it. Okay. When there's a lot of gravitational pull, then what can happen? Okay, temperature rises, gravitational pull is there, and there's nothing like luminosity because it's not burning. So as a result of it, luminosity decreases. Let me write down: temperature increases, luminosity decreases, and size reduces. So all the three are happening simultaneously. Now you see, temperature increases. Where is temperature increasing? Temperature is increasing in this direction, going in this direction, right? And luminosity decreasing. See, luminosity is decreasing over here. So all this points to this star only. Okay, so this cluster. Therefore, how should you write the evolution? The evolution might be this star is going like this, and after this you can show a vertical line like this, indicating like this. This will be your evolution. Okay, this is what you're supposed to write. So if you know the stellar dynamics, what's happening over here, understanding this is not very difficult because many of you think, should I write all this for just a 2 mark? You need not write anything. Okay, you should understand, and what is required for 2 marks is that appropriate arrows, their direction, and where does it fall? What is the final state? Okay, so you need not by heart anything. You should understand all this. Next, let us look at the next one. State the name of the object into which the star finally develops. What does it finally develop? White dwarf. This gives rise to white dwarf. Then the star will eventually fuse most of its hydrogen state the subsequent fusion process that occurs. Now, when it is happening over here, what is the fusion happening? It is not just so and so there, right? It is something like, yeah, helium fusion. Helium fusion is happening, right? Helium fusion is happening. And after that, once when the helium fusion is happening, what else can happen after this? The final product that will occur in this star, what will happen? The final product here would be ARP. Okay, so these are the type of questions that one can get using HR diagrams. So astrophysics in that part is not very difficult. It's quite easy. You can easily score marks in this. So see to it that you understand the concept properly. Okay. Thank you. So before leaving, do like, share, and subscribe to my channel. Share it with all your friends, and this really helped me and the YouTube algorithm figure out appropriate the what you call the videos, okay, to you. And don't miss to join my WhatsApp group, so wherein I'll be putting across lots of updates regarding what kind of videos I'll be putting across and so on. Thank you. Okay.